Hello, this is Michael Shakib from Swansea University, and I'm back again to talk about some other things about project finance. So in front of you here is a project finance model. It's for a 5 megawatt solar farm, which I did in a webinar as an example in a webinar on the 25th of July this year, 2025. And in this talk, I want to talk about discounted cash flow analysis, because some of the metrics that you see here, like net present value, project IRR, and all that sort of thing, they rely on knowing a little bit about discounted cash flow analysis. So unless you know that, you won't really know much about the net present value. I can tell you what the equation is for net present value and how to do it in Excel. And there it is, right in front of you there. It involves an equation which has got a discount rate, some future values of money, and an initial sort of spend. But yeah, unless you know about discounted cash flow analysis or have some sort of like appreciation of that, all that won't make a blind bit of difference to you. So let's have a look at discounted cash flow analysis. It's quite short. It's not a massive, it's not a massive deal. Once you get it, you get it. And then we can move on to looking at other things. Discounted cash flow analysis is one of those subjects where you could talk forever about it and it won't make any sense unless you show some examples. So let's go straight into the examples, shall we? So let's have an assumed we'll make up a project. We've got expenditure of £100,000 in year 0. We'll have a further expenditure. This is not something we've actually done yet, but let's just for the argument's sake, let's just say we have more expenditure in year 1, 2 and 3 and 4 of £10,000, and we have a revenue. We don't have any revenue in the first year, but in year 1 we have £25,000. We have £35,000 in year 2, £45,000 in year 3 and 4. Well, what's our total expenditure? It's £140,000, okay? So we've got £100,000, so we've got £140,000 expenditure. What's our total revenue? Our total revenue was £150,000. What's our return on this? Well, it's £150,000 minus £140,000, it gives us £10,000. Is that good? Are we happy with that? Well, let's consider something. Let's consider something before we start, and let's try and answer that question, okay? So a lot of the cash flow here is made in the future. It's made in years 3 and 4. Well, it's made in all of the years in the future. So ask yourself this. Is £45,000 in 4 years' time worth £45,000 today? It seems a really strange question to ask, but, well, first of all, the answer is no. And secondly, it's not really that strange question to ask once you know about it. It introduces the thing called cash flow, discounted cash flow analysis, I should say. And it's based on this premise that a pound earned or spent tomorrow is not worth the same as a pound today for a few reasons, okay? There's a few reasons why it's not worth, why those two things are not equivalent. There's a time preference for money. People would rather have a pound in their pocket today than a pound in the future. To make it equivalent, we need to be offered a pound today plus some additional sum, okay, in the future to forgo the use of that pound today. And it comes up quite clearly when you give this example. So someone has the ability to lend money and charge interest on it. So therefore we can forgo the use of a pound today in order to receive a pound plus more money, which is interest, in the future. For example, if we invest £100 at an interest rate of 10% per annum, we would expect to draw £260 in 10 years' time, and you'd have to look up compound interest for that, but we'll be doing that later on. We can say that £100 has a future value of £260. So £100 today has a future value of £260 in 10 years' time at an interest rate of 10%. In another way, we can say the present value of £260 in 10 years' time, okay, at an interest rate of 10%, is £100. So we've just said the same thing there, but two different ways round. Discounted flat cash flow analysis, DCF, tells us that some weighting should be allocated to a future cash flow, or cash flows rather, to reflect this time value of money. All right. Discounting lets us express sums of money in the future, okay, into sums of money today. And there's a mathematical relationship, which is VP equals Vn over 1 plus R to the power n, where VP represents the present value of a sum of money. VP is the present sum of money, Vn, in n years' time, okay, subject to a discount rate of R. Now we'll discuss what a discount rate is, alright? So this is your present value of money. This is a future value of money. And R is your interest rate. And R is a discount rate. And N is the number of years. So when does this become apparent then? Let's have a look. Let's say you've got two options. You need to choose between these two options. Option 1. Today I can pay you a guaranteed £100. Alright? Or option 2. In 1 year time, I can pay you a guaranteed £110. Now that's a guarantee, okay? That's 100% going to happen. This is zero risk money. Alright? Well, you can ask yourself, well, assuming I don't actually need this money today, I could take this money and I can put it in a low risk bank account and I can get an interest rate of say 5% from that bank account, and let's see what happens. Well, alright then. So we can put this into the equation. We can say that a VP equals Vn over 1 plus R to the power n. So let's rearrange this equation for Vn. We can say, well, how much is a future sum of money going to be given a present sum of money, which is £100? So we can work it out. We can say that Vn is 100 multiplied by 1 plus R, which is our interest rate, 5%, so that's 0.05, to the power of 1, because we have n years, and we're talking about 1 year. So in 1 year is represented by the number 1, so that gives us our 1. So our Vn is £105. So in 1 year's time, £105 has the same value of £100 today. So let's have a look at that then. So if we took option 1, we can take our money, we put into a bank account at 5%, and in 1 year's time it will grow to £105. Alright? What about option 2? Well, option 2, they've said, well, I'll give you £110 in a year's time. So for option 2, we started off with £100, and in 1 year's time, you're going to give me £110. So therefore, in this scenario, you would be correct to choose option 2. This is quite the purest way to think about it. What about thinking about it the other way around, though, okay? I can say, well, okay, I've worked out that if I'm given a present sum of money, £100, in a year's time, at 5%, it's going to be £105. And we know that we can do that in our head, okay? What about option 2? Well, can I work out what the present value of £110 is? So this is in the future. Yeah, this is in 1 year's time, £110. What's the present value of that? Well, let's work it out. VP equals Vn plus 1 plus R to the power n. So my present value of this is £110 divided by 1 plus R to the power of 1. What is R? The discount rate. Right. Well, it's the discount rate. I can get quite complicated to explain, and we will explain it later on. What this really means, without delving deeper into discounted cash flow analysis, I'll give a brief explanation in the coming slides. But for now, let's assume it's 5%, simply because we're trying to compare two different scenarios fairly against each other. So let's do this. We can see that in the scenario 2, our present sum of £110 in a year's time is £104.76. So in option 1, we went forwards in time and said that we grow our money by 5% in the bank. In option 2, we looked at the sum of money in the future and we discounted it back to the present value. So that's what we did. New question. If we were offered £105 today or £110 in a year's time, in 1 year's time, which one should we take? Well, the answer is obviously £105 today then, isn't it? Because we can grow that £105 to something larger than that in a year's time. Because £110 in 1 year is only worth £104.76 today, assuming a discount rate of 5%. Here's a bonus question for you then. Work out the they work out the value of £105 in a year's time using a discount rate of 5%. Go and do it. Okay, I'm not gonna, it's not a test or anything. Just have a look. Okay, so we've chosen 5%. In this case, we're comparing two investment opportunities, one against each other. So, and we're also assuming here that we can't get a higher rate elsewhere. But in reality, this discount rate can be quite tricky. It can be quite a tricky concept to manage. And so therefore, how do we decide a discount rate in the real world? The discount rate is the rate of return that you require or expect to earn from investing in the project. It represents the minimum return that you would accept for investing your money elsewhere, which is what we've talked about there. The higher the discount rate, the lower the present value of the future cash flows, and vice versa. We'll see that. The discount rate should reflect the riskiness and uncertainty of the project, as well as the time value of money, which means that $1 today, is America, is worth more than $1 in the future. Now, there's different ways of calculating the discount rate. There's the cost to capital approach, the hurdle rate approach, there's sensitivity analysis, there's market data approach, and then there's judgment and intuition approach. I'm not going to go through all of those in detail. You can read them for yourselves, and you can actually form your own not opinion, but thoughts on what this discount rate really shows you. Because if I just read these out, it means nothing. Okay, I can't explain it any better than what's written here as well. This is a website which you can go on and you will get a good overview of what the discount rate is. Go on YouTube, go on Google, search it, and when you come to the end of this course, you'll be able to have a better understanding about what question to ask.